Hi, everyone. It's Judy Warner. Welcome back to the OnTrack podcast. Today, we're delighted to be joined by Natasha Baker, the CEO of SnapEDA, who had a vision to make component selection and making models as easy as doing a Google search. So I know you're going to enjoy learning from Natasha Baker. So lean in, enjoy. I'll see you on the other side. Welcome to Altium's OnTrack podcast, where we talk to leaders about PCB design, tackling subjects ranging from schematic capture all the way to the manufacturing floor. I'm your host, Judy Warner. Please listen in every week and subscribe on iTunes, Stitcher, and all your favorite podcast apps. And be sure to check out the show notes at altium.com/podcast, where you can find great resources and multiple ways to connect with us on social media. Hi, Natasha. Thanks so much for joining us today. We're delighted to have you.
Oh, thanks so much for having me, Judy.
Well, it has been a long time coming, us actually meeting and doing this podcast. We've been trying for quite some time. So I'm really excited to share you. One, I was excited to meet you, but now I'm really excited to share you with the OnTrack audience. So why don't you start out by telling us a little bit about your professional and educational background, and then we'll start learning a little bit about SnapEDA.
Sure. Yeah. Thank you, Judy. And so, I'm an electrical engineer by background, and I've been in the EDA industry now. I started in the EDA industry 14 years ago, so it's been a little bit of time. I started my career over at National Instruments, and actually my internship was focused around reading the IPC compliance handbooks, and that's actually how I got started in the EDA space. So basically spent a couple years there in R&D. And then moved over onto the marketing side, and I was responsible for marketing their professional design tools at the time. And it was actually there that I came up with the idea behind SnapEDA. So that's a little bit about my background.
Great. So tell us about your sort of what disconnects you were noticing back in those days, and what sort of inspired you to create SnapEDA.
Sure. Yeah. So I was actually designing a circuit board for a trade show. So one of the things that the applications engineering team at National Instruments had done is they'd made this really cool demo using their data acquisition software that could actually allow people to use their eyes to control a Nintendo game on the screen. And it was a super cool demo. And someone in our company was like, well, why don't we adapt that to just a circuit board that's made using our design software? And I was like, well, that's a really cool idea. I'm going to make this circuit board. We're going to attach it to a Wii steering wheel. And because Wii was big at the time. And then it would control a Nintendo game on the screen. And so I found a reference design from Texas Instruments of an accelerometer and decided to start designing this, what should have been a very simple reference design to do this demo. And it was actually while doing that I realized, well, I can't find any of the libraries that I need to design this circuit board. I need to make all the symbols from scratch. The footprints, I can't even find simulation models, and making a simulation model is obviously really challenging. Right. And it was in that moment that I realized, well, why isn't there a Google for electronic components? A place where engineers can go to get all the design data that they need to focus on innovation and building cool things and building cool demos for trade shows. And if someone could have that, just think of all the cool things that they'd be able to build a lot faster. So that was really the genesis for creating SnapEDA and kind of the moment of inspiration, I guess you could say.
Right. Well, it's no small problem, and I'm impressed that you decided to take on that big of a challenge. So, as you said, these things weren't just readily available, and a lot of design engineers still today are building their own models, if they can't readily find it. What are some of the sort of pervasive problems you're seeing in the industry, and then specifically the types of things you're doing at SnapEDA to address them?
Yeah, so we always say that the biggest problem that we're solving is trust, because it's not enough to just have access to the CAD models, but engineers need to know that they can trust them, that it conforms to their company guidelines, and things like that. So that's really been the biggest challenge that we've had in creating this. And I think the biggest barrier in companies embracing it, embracing third-party libraries, but that's really been changing over the past, I'm sure you've seen it as well, but over the past like 3 to 4 years, especially, we've seen a lot more larger companies who typically in the past would have had librarians, either, not having them anymore, or just having smaller pockets that don't have access to the librarian, right? And so these companies are going and looking for, content online. And of course, the number one thing they wonder about is, can I trust this data? And that's kind of like the number one thing that we really focus on.
Yeah. Well, Natasha, as an aside, so one of the stories I heard that makes me think a lot about the work you're doing here and what you just said about we're sort of losing this body of dedicated PCB librarians and things, which it seems to be going by the wayside. We knew a customer that he was a design manager, and he called them rogue libraries, right? Where he had the central data library for a large company, but then all the design engineers would build these, what he called rogue libraries, Bob's, Bill's, Susie's, right? And so to your point, how do we know? How do we know there's not the same thing on two computers? How can another design engineer, and created all this disconnect? And he kept saying, no, you guys were centralizing the library. We need to do this thing. And they weren't complying. So one day on a Friday, he deleted 1,200 rogue libraries.
Oh no. I can only imagine the lashback he probably got from that.
Right. And I'm like, did you go to work on Monday? But it was a, tough love, but they did recover. But I think, he was addressing that same issue exactly that you're talking about.
Yeah.
Is all the lack of transparency, the lack of known reliability of the data.
Yeah.
So one thing that caught my attention that you talked about as you were developing things for National Instruments, but I know it's a big thrust for you now, is to make sure that these models and things are compliant with IPC. And how does that sort of pan out, and why exactly is that important in your mind? I think I know, but
it's not even always IPC that's important. I think the biggest thing that's important is consistency and transparency. Because for certain components, like IPC doesn't even cover them, like electromechanical components, for example, connectors and things like that. It's actually better to follow the manufacturer's recommendations in those cases, because they're just as much mechanical components as they are electronics components. So it's not so much, hey, we must rigidly follow this standard. It's more around, does it follow a standard? Which standards does it follow? And how do I know which standards it follows? Right. And so the way that we do that is we'll always indicate on our product pages that, hey, this is made with manufacturer recommendations, or this is made with IPC recommendations. A lot of engineers coming up, they're not necessarily familiar with IPC, especially if they're smaller companies. Mm-hmm. And they actually, for them, they're like, they really want the footprint to conform with the data sheet. We see that a lot, actually. But yeah, so the way we think of it is we make IPC by default, just because it is, they've done a lot of research and into manufacturability. And a lot of the times it is more rigorous, the approach, than the data sheets might have, especially for standard ICs. And then we make that by default. However, if we work with a supplier and they're like, hey, we really, especially connector companies, will designate, hey, this was made in collaboration with that particular supplier. So that's one way. And then the other way is we show different kind of checks on each page that engineers can take a look at and see okay, is the silk screen at least this amount away from the copper pads? And they can kind of get transparency into those elements that matter too. So yeah, I think, the biggest thing we've seen is, again, to your point around this librarian who had all these rogue libraries. The reason is probably that he didn't have that transparency into, did they follow the standards? And he also had that knowledge that it's going to take me at least 1,200 hours to verify all these, right? That's the other thing we hear, is that, it's going to take me just as much time to verify this library as it is to make it myself.
Exactly.
So that's really the problem that we're solving, is how do we do that more and more and communicate that?
It's just amazing. I love this work, and I know our listeners are going to love hearing about it. What are some of the other things, you mentioned doing CAD, CAD models, footprints, obviously for that. What type of other things are you doing in relation to the services and that you're offering through SnapEDA?
So schematic symbols, which again have lots of preferences around how those are done as well. A lot of preferences. Footprints, 3D models. We started expanding to simulation models. So we have some IBIS models, some SPICE models, but it's totally a new area for us. And then we've also started adding reference designs as well. So we're still in the early days of those other forms of content. Today, I'd say our main coverage is in the symbol, footprint, 3D model space, and that's kind of where we've really focused the most. So yeah, those are like the main content. But again, the same philosophy around those types of content, right? Which is, I guess, three things. So like breadth, making sure we cover all the different components out there. And I don't know if you've heard the stats on how many components are out there. But
no, let's hear it.
So IHS, apparently they have a billion components in their database that they manage. So billion components. So breadth is a big one, is making sure we have coverage for models for all the different components in the industry, which is absolutely massive. It's actually nuts. It's absolutely mind-blowingly nuts. So that's one. Interoperability. So making sure that, we are compatible with all the different places where an engineer might want to find these components and the different, places and tools and things like that. And then finally, transparency and quality. So that's kind of how we think of the design data space. And before we kind of pursue any of those spaces at scale, I'd say we're more in the experimental stage in the simulation model space right now. But before we do any of those at scale, I think that's kind of the main things that engineers really care about.
So how many visitors do you get to SnapEDA, say in a month or so? How many people are on your platform?
So I think it's about a couple 100,000 unique each month, and then over 1 million each year that come to our site. And and I think this kind of is more a point to the innovation that's happening everywhere in the world, right? Like it's literally every single country now designing electronics, and everyone from tiny little startups to large OEMs to even companies that you wouldn't even imagine designing electronics. Companies that do so many consumer companies. It's so interesting and exciting to see all the consumer companies who are designing stuff now, and they're making such cool products.
Yes.
So yeah, it's an interesting time to be in the electronic space for sure.
It sure is. And as you're pointing out, it's the IoT, right? It's IoT. So now there's electronics in your sofa, for heaven's sakes,
Yeah.
And so it's getting pulled into spaces or whatever spaces we've never been in. And so
I'm actually curious about that application, the sofa application. Do you know what they're doing? Or
no, I don't, but I know that you can do things like charge your phone or maybe make adjustments. So it's just, I'm like, oh my gosh, there's electronics in our sofa.
Absolutely.
Or they also have like end tables where you can do wireless charging of your phone, the timers, temperature gauges, just all kinds of like, some of it's sort of silly. Somebody was just talking about a toaster with the IoT, and it's like, really? Do we need that to make bread crusty?
I have to say that I love those kinds of things. I'm such a sucker for every like gimmicky IoT product. I don't know. I just find them really cool. Like I can't even go back to a non-Wi-Fi connected scale because I just think it's so fun.
I know. That means you are officially a geek. Okay. Before we continue, I haven't done this in a while, but I want to do it because of what you just said so I always think there's this really common thread with people that go in engineering, and you sort of self-identified yourself right there. So when did you know as a young girl or a woman that you would you probably be an engineer? What markers were there along the way?
It's an interesting question because I wouldn't say that I had a typical aha moment like other people. I think I just grew up in a very entrepreneurial family where my parents had a bookstore, and I was always the type of person who, I worked a lot in the bookstore growing up just because it was like family responsibility. And
right.
so I was always thinking of like, just different processes around how to manage their books. And, I helped them start selling online and help them set up processes to track where the books were, and just was doing all this stuff. And at the same time, anytime they had like networking issues with their computers, I would be helping with that. And like, just from a very young age. So
Right.
I wouldn't say that I was necessarily like, I was always into technology. And I always, every time we got like some new technology, I was like, I wanted to set it up,
Yes.
But I would say that I think it was kind of a mix of both. It was kind of like, I had that entrepreneurial sense. I wanted to help, I wanted to help market the books, like make nice displays. Like I kind of just always wanted to solve problems, So I think it was like, it wasn't so much an aha moment of like, I need to go into electronics, but I think that when I got into engineering and I did electrical and computer engineering, I think what I realized was like, wow, I'm really where I should be, because, thinking back on all the things that I really loved when I was a kid, like I remember watching some, movies. I think it was like Pee Wee Herman's Big Adventure, where he automated all the breakfast.
Oh yeah, that was so cool.
It was so cool, right? And I always thought that was so cool, and I'd like love to do that, but I never tied that with like, I could do that, or that should be done, frankly.
Yes.
But it was just more of a moment of like, that would be really cool. I'd love to build that kind of stuff. So I wouldn't say it was like a conventional approach to find,
No, but it is. And it's interesting to see how you had that mix of entrepreneurial spirit and curiosity, which curiosity to me is like the underlying thing that I sort of see across the board when people enter technology or engineering, is this sort of insatiable curiosity and tinkering and problem solving. But that it's interesting because of the entrepreneurial spirit, you've sort of touched many aspects of business. So that's a really neat, it really makes sense what you're doing. And I would agree. I think you're just the right spot. So do people just go online to access SnapEDA? Do you have plugins? Do you have APIs that can be embedded? Like, how is that? What's the delivery system, or how people access?
Yeah, so we have SnapEDA is available obviously on the web, on our site. We have plugins. So we're doing an Altium plugin beta program right now. And we have 300 people in our beta program who are trying it out and giving us feedback and things like that. And we're getting very good reception. And then we have other tools as well. We do have raw APIs. And then it's available on distributor websites too. So if you go to DigiKey, if you go to Mouser, you'll find SnapEDA models on there too. So yeah, we kind of, the way we look at it is like, on our platform, what you'll get is a lot more of the tools. We have different tools for helping you build components, as well as the libraries, all the checks and things like that. But increasingly, we're starting to expand outwards to kind of different tools as well. So that we can provide them with our libraries. So yeah, those are probably the main areas.
So you showed me something super cool the other day. So tell our audience a little bit about Instabuild.
Sure, yeah. So one of the things that, being that there's a billion components out there, according to IHS, one of the biggest challenges is just, how do you create all those components? So we've created various automation tools over the years. And one of those tools we've released to engineers is called Instabuild. And what engineers can do is they can highlight a pinout table. And when they highlight it, we use computer vision and OCR to extract the pin names, pin connections, and then it automates a symbol based on a logical design of a symbol. So inputs on the left, outputs on the right. It can auto detect pin types as well to configure the symbol. And then we attach it to an IPC compliant footprint and do all the pin connections. So that's just an example of like one of the things that engineers can find on our site. It's totally free and can help them automate symbols a lot faster. So those are the types of tools where, our goal is to just keep evolving kind of what we have. And, it's a challenging problem. There's a long way to go, but that's one of the examples of one of the tools we've released.
I think that's so cool. I think that's just such a great thing. The way you literally showed us how you just highlighted the table, drug it over, and like, boom. So to our audience, we're going to put the link to the SnapEDA website below, and you should go check out Instabuild and just click around. There's some amazing tools that you will fall in love with, I think. You also mentioned accuracy and transparency a couple times. So, transparency is a word we toss around a lot in business and electronics. Can you talk about why in this particular way it is so, like, define that a little bit further and tell us more about that?
Yeah. So by transparency, I mean kind of what are the limitations of this model? Under what are the standards that it follows? So, for example, in a SPICE model, just for example, it could be what frequency range does this model work under, right? Because a lot of the time when people are making models, they don't model every single behavior that can happen at really high frequencies, right? So an example of that could be, okay, here are the conditions upon which this model is reliable and will work. For a footprint, it could be this, again, the standard, right? So there's even the IPC, for example, defines different standards of density where that model will be a good fit for. So explaining to users that, hey, this is under these conditions, this model will be a good one for you. And if you're doing maybe a super dense application, you might want to reconfigure the pads or use another density level. But I think the biggest thing there is just helping engineers understand when they should be using that particular model in which conditions. So yeah, that's really what we mean by it, but also transparency around the quality, because with automation, there's a lot you can automate, right? So there's a lot you can't automate still. I think especially around computer vision. And I think computer vision on data sheets isn't quite at the point where you can extract everything reliably, because even for humans, reading data sheets is hard. And in some cases, just the data sheet is just like not very good, as we were talking about. But I think when it comes to automation around the verification or automation around the creation of the component, there's a lot that can be done and a lot that can be shown to engineers. So as I mentioned earlier, whether a pin is defined correctly, right? For ERC checks, that a ground is a ground, a power is a power pin, an input is an input. And that's something that can be automated for the most part, right? I mean, sometimes it can be challenging to understand what a pin is, but in general, you can automate that and give engineers that transparency so that they know that, okay, I can trust this. I don't need to spend 3 hours verifying it.
Yeah, which is so not fun, to spend that much time getting in the weeds. So in that comment, you sort of mentioned data variance and accuracy. You'd also mentioned to me the other day about the problem of universal file formats.
Yes. Yes. So universal file formats. So in the PCB industry, as I'm sure you know, every tool has its own file formats, which can be really challenging. Sometimes they'll have importers, but even then they may not be up to date. They may not. So the challenge has been that we need to create exporters for every single file format that's on our website, which can actually be quite tricky depending on how well documented their file formats are, if they're open or if they're closed. If they're open, it's very easy. If they're closed, it's a lot harder because we need to build the relationships and things like that, and it becomes more challenging. But yeah, one of the challenges for us for a long time is we were exporting the Altium format using a former PCAD format. And it was really challenging to import. It didn't have all the latest and greatest Altium features. But just this year, we updated our Altium exporter. So we support the intlib format now. And engineers are really happy because the PCAD, the older PCAD format was just not as robust.
Yeah.
But to your point, it's just a challenge, and the file formats change. One of the major EDA tools just changed their file format. So now we need to create a new exporter to update all the file formats to that. And then of course there's also just challenges in terms of different ways the EDA tools handle the different elements, because some people might represent different symbol shapes as lines or rectangles, and so we kind of need to be able to be fluid with kind of how we export the data so that we can conform to what's most native in that tool, and that can be very challenging as well.
Yeah. And like you said, a moving target. And another thing you mentioned to me, which we've seen here at Altium as well, is about a non-obvious one, which is just, I'd like to hear from your perspective, is just sort of the built-in preferences of each design engineer.
Mm-hmm. Yeah, totally. So, and I understand it. I mean, engineers, like, I'm so glad that they care about that, because they care about craftsmanship and they care about their designs, and that is, I mean, of course, that's what we want, and that makes sense. But yes, there's so many different preferences, and it's challenging to support all of them, whether that's, the silkscreen line width, or whether that's how they want their symbols configured. I always thought, based on talking to a lot of professional engineers, that they wanted a logical symbol, right? So
right,
inputs on the left, outputs on the right, pins grouped logically, things like that. But we actually just ran a survey, and a large chunk of people said, I want it to look like the application circuit symbol. And these were like professional engineers that, many of them saying that. So I don't know if it's a shift in the trends. We have to look into that a little bit more, or if it's maybe a certain segment was overrepresented. But yeah, there's things like that. There's things like no connect pins on the symbols. And do you want those there or not there? So there's just so many preferences. So that's the other thing that we're starting to build into more, is just letting people customize it a little bit more to their needs. And, one of the big things too is like customization of layers. A lot of companies will customize the layers that they use. So being able to be versatile and export the various layers to the layers engineers need and things like that is another kind of area.
Natasha, you are so brave. This is such a complex problem that you guys are either that or you're a glutton for punishment. I'm not sure which one.
Yeah, I don't know which one it is
either. So during this whole COVID season, Natasha, what have been your observations, or has this had any impact on SnapEDA, or the kind of engagement you're seeing? Or
so not really. Like, I mean, we definitely didn't see any drop from COVID. We definitely saw a shift in how people are designing, what they're designing in certain cases. But overall, I would say no. I mean, it's been very steady. And in fact, we had a large uptick in September as soon as people got back to school and back from vacations. Mm-hmm. Yeah. So I think being in the electronics industry, we're very fortunate. It's very resilient. Yes. And also, I also just think that, there's such a demand for electronics that the demand just it's still strong. So yeah. It's good.
Yes, I feel like we're some of the fortunate ones as well. That shift in the types of electronics, do you think that was, sort of a reaction to, say, ventilators or medical response, things like that?
Yeah, I mean, there was definitely some of that. Like it was interesting. There was a user who typically they make connected toys, and they were shifting their entire design processes to focus around helping with the ventilator cause. So that was pretty interesting to see that, and just kind of the change, like how people could adapt so quickly, and really inspiring.
Yes.
And yeah, I'd say kind of, we definitely saw a lot of activity in the medical space, and also in networking. So things like, of course, to power Zoom and like data center type of stuff. And that's the other area where we saw a big uptick. And, speaking to some of our partners as well, on the supplier side, component side, like they've seen, just a big uptick in those areas as well. So it's really aligned with kind of, I think, where the world was, going then.
That's interesting. So yeah, we've seen some of that as well. And I also have found it really inspiring to see the electronics industry come to bear on this really global problem. It's been really fun to watch. So as as we sort of get towards wrapping up here, I'm really interested in hearing your perspective on sort of forward trends as you look ahead, like, where do you want to go? You've got some things that are sort of in beta phases, or, like the simulation that you mentioned. So what do you see as trends for SnapEDA, but what do you also see as trends in engineering in general? How as you said, the face of engineering is changing and evolving all the time. So Just from your perspective in the industry, Natasha, what are you seeing?
Yeah, I mean, for us, I think we've definitely seen over the last few years, engineers embrace, ready to use content. And that's something that 6 to 8 years ago just was not the case. People, would tell us, hey, we have librarians, or this is part of my job. So I think maybe 3 to 4 years ago, we saw this massive shift. And what we're seeing is that engineers, and it makes total sense in other, I think if you talk to other industries and things like that, it makes a lot of sense, right? That people just want more content. So, I mean, number one is we're going to continue to expand the types of content that we provide, the breadth, the transparency, right? So we're going to continue to do that. But I think that what gets more exciting is thinking about our larger mission, which is to help engineers design faster by removing barriers. Like, I think in terms of where we're going, I think design's just the first step, like design data. Because I think that data is just kind of where you can't really do a lot of interesting stuff until you have data, And
reliable, known, good data, right?
Exactly, viable, known, good data. Because if you can't jump to automating reference designs and things like that if you don't have a good foundation.
Yeah.
So I definitely think we're going to do two things. We're going to continue to expand what we have today at kind of like the discrete level, but then also start looking up the stack as well. So looking at, okay, not just the models, but also how do we expand to larger pieces. But I think if you think about our longer term vision, it's really about how do we anticipate the needs of engineers right when they're designing? Because when we have the data, then all of a sudden we can be that guide, we can help them, we can assist them right when they're designing and give them recommendations about how to design better, how to not dig up data about which decoupling cap they need when they place down a particular component, and things like that. So I think looking ahead at the longer term trends and kind of what we're seeing and kind of how that ties into our vision, I think it's really just about, technology is enabling people to kind of get what they need fast and like right when they need it, so they can focus on what they need to do, which is inventing and innovating. And our mission is really just to enable that. And by doing so, we can enable the engineers to do what they do best, which is making all these great products that improve our world and bring it forward, and that's what motivates us and keeps us going, is kind of working towards that vision. And yeah, I mean, so far, everything we've seen is like points to the fact that, it's kind of intuitive, right? I think it's just engineers want to focus on designing and inventing and building great things. And so, yeah, so that's kind of our focus.
Yeah, well, that's so much in alignment with the vision that Altium has as well, Natasha, and that is that we want to make it easy to, right? So if you're midway through the design process, you can grab these things right in your design tool or simulate or whatever. We don't want to sort of be in the way of the innovation, right? We want to ease the path to innovation and help them not spend so much time. What they're good at is engineering, innovating, and that's what drives them. They're puzzle solvers. They're, who wants to spend a day doing documentation or checking data sheets? That's not why, that's not what they were meant to do. So we're right there with you, and I love it. And I love what you're doing.
Altium's right in the forefront of that. So yeah, it's definitely exciting to see what you all are doing, for sure.
Yeah, well, it's fun to be part of. I can tell you that. I love it. Okay, last thing I want to talk about is you'd mentioned something that I've been seeing as well, and that is sort of this shift towards, as you said, way back when I started, there was the circuit engineer would do a schematic and hand that off to the PCB designer that would hand it off, that would work with a librarian, and there was all these things. But now it seems like engineers are being asked to do more with less, right? And so they're moving towards this sort of system-based and multidisciplinary engineering. How are you seeing that show up sort of with what you're observing as SnapEDA?
Yeah, we're seeing it really, from companies like small to large. So at small companies, it's really just the expectation that they need to do basically every stage, whether that's the libraries, the schematic symbols, the footprints, everything, the mechanical, the firmware. And I think that's kind of reasonable. Like startups, okay, you have these do it all technical people, but we're even seeing it at large companies. So I can think of like billion-dollar OEMs off the top of my head who have smaller teams focused on particular projects. And they've told me, we're tired of being at the office till 10 p.m., 11 p.m., doing everything ourselves, doing libraries. Libraries is the big one that you can think of. Okay, we can outsource that, right?
Right.
But that's what's happening, because either they don't have access to the librarians, or their companies don't have librarians at the company at all, or they want to move around them because the capacity is too high for the librarian. The librarian can't keep up, so they go and make their own libraries. So I think, but thinking of it at like the meta level, I think it is something that engineers out there, they do need to, I think, we were talking about it earlier. It's like this requirement to be resourceful, this expectation, because there is this kind of, in a lot of companies, people are just so multidisciplinary and they need to be kind of knowledgeable in so many different areas. So yeah, it's been really interesting to see. And also just that it's not just at like small companies either, that it's also the big companies.
Yeah. Well, we certainly see it here, more of a demand for systems. And I think, to your point, the resourcefulness is huge. And it's something that I've been excited to be part of, say with All Team Live or whatever, is to kind of plug people into resources and people. And, if we have sponsors, say for All Team Live, to put them in front of companies like SnapEDA, fabricators, assemblers, where they can go get the resources and the knowledge. And, hopefully here in the next year, we're going to be doing more and more education, because I think education and resources is the number one need of engineers today. And it's just like SnapEDA, it's a complex problem, and there is no like one pat answer. These aren't.
I think it's an effort between, everyone, including the design tools. And I think All Team's doing an incredible job with that, just taking away the complexity and making it easier, right? And I think as the tools evolve, that it is, and I think that's one of the reasons why they're even expected to do all these things, right? I think the tools have evolved to the point where you are able to figure them out without as much like effort as you used to be.
Yeah.
And things have simplified, so I think it's a team effort across the EDA tools, the mechanical tools. Like I think as those tools evolve and get easier, it's actually a great thing, because it's going to open up access to everyone. And I think that's part of the reason why we're seeing hardware engineers doing electronics doing more hardware, like, and vice versa, because the tools have evolved and things have simplified. So I think it's a great thing.
Yeah, as you said, exciting time to be part of this industry. Well, Natasha, have loved getting to know you and finally getting to connect and learn about all that you're doing. Excited about what you're doing. And I'm absolutely positive that our listeners are going to enjoy. We just loved having you. So thanks so much for joining us today.
Thank you so much, Judy. I appreciate the opportunity.
Yeah, anytime. So for our listeners, I'm going to have Natasha give us a bunch of links for places you can go to learn more and tap into, and just take a look at what they're doing at SnapEDA, and wholly plug you into a great resource here with SnapEDA. So thanks so much for joining us today. Remember to go subscribe here, because that'll help us keep serving up content about things you care about. So thanks for joining us today. Remember to stay healthy, stay safe, and always remember to stay on track.